thinking about three main things. Woo! We're thinking about air pressure, which is the amount of collisions. A lot of car crashes, a lot more air pressure. We also have to think about the temperature. Remember, temperature is a measure of the average kinetic energy of the particles. Woo! So how fast on average are the particles moving? If they're moving faster, it's hotter. If they're moving slower, it's colder. And then we look at the density of the air, which is mass over volume. Woo! So it's how packed the gas particles are in space. So we think about pressure, temperature, density. Wind is just movement of air. And air is going to move because of the difference in temperatures and the uneven heating of our Earth. Woo! So it all goes back to the sun. Remember, our Earth is tilted at a 23.5-degree angle, and it rotates. So not all parts of the Earth are going to get the same amount of sunlight at the same time. And that difference in the amount of sunlight is going to lead to a difference in temperature. Woo! So the atmosphere is going to have different temperatures. And this temperature difference is going to cause the air to move. Remember, things that are hotter, the atoms in those things are moving faster. More kinetic energy. If they're moving faster, they're spread out and they're less dense. So they're going to float. They're going to move up. Things that are colder, cold air, is more dense because the gas particles in the colder air are not moving as much and they're more packed together. And the cold air is going to sink. Warm air rises. Wind is really due to the air pressure and the density differences in the air. So air is going to flow from high pressure to low pressure. So they're going to go from there's high pressure to where there's low pressure. Here we have temperature in the middle, volume, pressure over here. If we keep the volume the same, if we're looking in the atmosphere, we're not going to change the volume. As the temperature goes up, woo! As the temperature goes up, the pressure goes up. So as the temperature goes up, that means the gas particles are moving faster. They're moving faster. They're going to crash more often. Just like on 280, the cars are going all different directions and they all speed up. There are going to be more crashes. So there's a higher pressure. So hotter air has more pressure. High pressure, hotter air. Now if we look at temperature, it is cooler. Woo! The pressure goes down. So cold air has less pressure. So just like on Highway 280, the cars, let's say the cars are the atoms. Woo! The cars slow down, less average kinetic energy, lower temperature, less chance of having collisions, less chance of a car crash. So less chance of a car crash, lower pressure. So the air is going to move then from high pressure, hot air, to cold air. So it's going to go from the hot air masses to the cold air masses. And that movement is wind. There are different types of winds. Okay, there are some winds that are local, that we have only in San Francisco, in the Bay Area. And then there's some winds that are global. Really, they go pretty much cover the whole globe. So if we look at the Earth, the highest part of the Earth then is going to be the equator because it's getting maximum direct sunlight all the time. So that is going to have the warmest atmosphere, that area in the middle. The poles then, North Pole, South Pole, they are going to have the coldest atmosphere because they're not getting the direct sunlight. So if warm air, we now know, rises, right, because it's less dense, the air around the equator, the atmosphere around the equator, that air is going to move toward the poles. poles. So here we have the Earth. Now everybody's gonna, I want you to please draw this. Let's draw the Earth and have heat. It's going from the equator to the poles. Cold air from the poles then is going to go toward the equator. This is due to the difference in air temperature on the Earth. Okay, so the difference of air temperatures and the rotation of the Earth leads to what is called Coriolis Effect. So due to that rotation of the Earth and the difference in air temperatures, this leads to kind of a distortion of the path the air is going to travel. So it's not just straight down and straight up. And we call that the Coriolis Effect. The equators here, these are lines of latitude. So latitude, horizontal lines going across. 0 degrees is the equator. Right here, 0 degrees. Okay? Now if I were to make a line, it's 30 degrees. So this is 30 degrees latitude. If I make 60 degrees is the 60 degree latitude. 90 degrees is here at the North Pole. Same thing down here, this is going to be negative though. When we look at this, due to the air temperature difference and the rotation of the Earth, we have this Coriolis effect, which means that the winds are not traveling in a straight path. They're actually going to move toward east or west. And we can use that information to predict weather patterns all over the world. So in this, at about 30 degrees latitude, the wind travels like in this direction. So it goes upward like this. Okay, negative 30 degrees, it's going down this way. So it's not just going to the poles because the Earth is spinning. So it kind of distorts the path of the wind. So the winds that are close to the equator are called trade winds. Woo! So close to the equator, trade winds. These winds going this direction are called the Westerlies, the westerly winds. They're going west. And then up here we have the easterlies because they're going to the east. Woo! And they're polar, so it's polar easterlies. And remember, differences in air temperature and the rotation of the Earth causes the Coriolis effect. Another type of global wind is called jet streams. Now think about a jet stream. It's airplane. So it's a path where you're going to have airplane, so it's higher up in the atmosphere. Jet streams in the northern hemisphere really form at the boundary between the cold air from the North Pole, the warm air from the equator. So a boundary between cold, dry air from the North Pole and warm, moist air from south of that. So where they meet, that boundary forms what are called jet streams. And these are winds in the upper atmosphere. High-speed, powerful winds that happen where there's a boundary between cold, dry air from the North Pole and warm, moist air from south of that.